Imagine a place in space where gravity is so strong that nothing, not even light, can escape it. A place where the laws of physics as we know them seem to break down. Sounds like something out of science fiction, right? Well, welcome to the fascinating and mysterious world of black holes. So what exactly is a black hole? In simple terms, a black hole is a region in space where gravity is so intense that nothing, not even light, can escape from it. It's like a cosmic vacuum cleaner, sucking in anything that comes too close. But how does something like this form? A black hole starts its life as a massive star, much larger than our sun. Stars shine because of the nuclear fusion happening at their cores. Essentially, they're constantly battling gravity with the pressure created by these nuclear reactions. But eventually, the fuel runs out, the fusion stops, and that's when gravity wins. Without the outward pressure from fusion, the star begins to collapse under its own gravity. For smaller stars, this collapse might stop at a white dwarf or a neutron star. But if the star is massive enough, at least about 3 times the mass of our sun, this collapse continues until it forms a black hole. At the very center of a black hole lies what we call a singularity. This is a point where all the mass of the collapsing star has been compressed into an infinitely small space. Imagine taking something as massive as the sun and squeezing it into a point smaller than a grain of sand. The density here is infinite, and the laws of physics as we know them can no longer describe what's happening. Surrounding this singularity is the event horizon, often referred to as the point of no return. Once you cross the event horizon, there's no turning back. Not even light can escape its grasp, which is why black holes are, well, black. But what's really interesting is what the event horizon represents. It's not a physical surface, but rather a boundary where escape becomes impossible. The closer you get to the event horizon, the stronger the pull of gravity becomes. Time itself starts to slow down as you approach it, a phenomenon known as time dilation. If you were to watch someone fall into a black hole from a safe distance, it would appear as though they slow down and eventually freeze in time right at the event horizon. Now, not all black holes are the same. In fact, astronomers have identified different types of black holes based on their mass and size. First, we have stellar black holes. These are the most common type, formed from the collapse of massive stars. They can range from about 3 to 20 times the mass of our sun. Next, we have supermassive black holes. These behemoths can be millions or even billions of times more massive than our sun. What's incredible is that these supermassive black holes are found at the centers of most galaxies, including our own Milky Way. But how do they get so big? Scientists believe they grow over billions of years, possibly by merging with other black holes, or by continuously pulling in matter from their surroundings. And then there are intermediate black holes, which are like the middle ground between stellar and supermassive black holes. These are still a bit of a mystery, as they're harder to detect, but they might form from the merging of smaller black holes. Finally, we have primordial black holes. These are hypothetical black holes that could have formed just after the Big Bang from tiny fluctuations in the density of the universe. If they exist, they could help us understand more about the early universe. One of the most intriguing questions people often ask is, can we see black holes? Since black holes don't emit light, we can't see them directly, but we can observe the effects they have on their surroundings. For example, when a black hole pulls in nearby material, such as gas or stars, this material gets heated to extreme temperatures and emits X-rays before it crosses the event horizon. These X-rays can be detected by telescopes, giving us indirect evidence of a black hole's presence. Another way we detect black holes is by looking at the motion of stars or gas clouds that are orbiting an invisible object. If something massive is pulling on them, but we can't see it, there's a good chance it's a black hole. In 2019, the world was amazed when the first ever image of a black hole was captured by the Event Horizon telescope. This image, from a galaxy called M87, showed the shadow of the black hole against the bright ring of gas swirling around it. It was a monumental achievement in both astronomy and physics, giving us a glimpse of something previously thought to be unseeable. Black holes don't just affect the matter around them, they also warp space and time. According to Einstein's theory of general relativity, massive objects like stars and planets bend the fabric of space-time. Black holes, being incredibly dense, create such a deep curvature that they essentially create a pit in spacetime. This warping of spacetime is what leads to phenomena like gravitational lensing, where the light from distant stars is bent around a black hole, creating a sort of cosmic magnifying glass. It's also the reason time moves differently near a black hole. The closer you get, the more extreme the time dilation becomes. In fact, if you could somehow hover just outside the event horizon of a black hole, you'd experience time at a much slower rate compared to someone far away from the black hole. This is often depicted in science fiction, but it's based on real science. So, what would happen if you were unlucky enough to fall into a black hole? The closer you get, the stronger the gravitational pull becomes. Eventually, the difference in gravity between your head and your feet would become so extreme that you'd be stretched out like a piece of spaghetti, a process scientists call spaghettification. It's not a pleasant way to go. Once you cross the event horizon, all bets are off. According to current physics, you'd be pulled inexorably towards the singularity, where you'd be crushed to infinite density. But since no one has ever fallen into a black hole and lived to tell the tale, there's still much we don't know. Some theories even suggest that black holes could be gateways to other universes or different points in time. But for now, these ideas remain in the realm of speculation. Black holes are some of the most mysterious and fascinating objects in the universe. They challenge our understanding of space, time, and the very nature of reality itself. From their formation and their mind-bending effects on space-time, to the mysteries of the singularity at their core, black holes are a cosmic puzzle that scientists are still working to solve. Whether you're a space enthusiast or just curious about the cosmos, black holes remind us of how much more there is to learn about the universe we live in. They are not just holes in space, they are gateways to deeper understanding and new discoveries. Thanks for watching. If you enjoyed this video and want to explore more mind-blowing topics, don't forget to like, share, and subscribe. Until next time, keep looking up and wondering about the universe around us.